Cup of coffee contains 150 milligrams of caffeine. Let me auto lock this. Okay, that's not going to work. Nope. Come on now. Come on. There we go. A cup of coffee contains 150 milligrams of caffeine. If caffeine is eliminated from the body at a rate of 11% per hour, how long will it take for the caffeine to eliminate? So, you don't actually have a setup here, but you would imagine that caffeine is continuously being eliminated from the body at a rate, right? So we're going to use the PERT function. So we're going to go back to here. This guy is extremely useful. So we're starting off with 150 milligrams. Okay, how long before this caffeine is half? So we're looking for 75. So in our table, we're going to look for 75. We got e to the x. It's being eliminated at 11% per hour, which is that. But let's make sure that you put negative 0.11, because if you don't, you will be just increasing the amount of caffeine, which would be my case right now. So that right there is a negative 0.11%. Good. We're ready for the table. Let's see. We got 9 hours, 3 hours, and 6 hours. Let's try starting at 0. So we'll start at 0. Okay, so we're looking for 75. So it looks like it's in between 6 and 7 hours. Okay, so we're going to say about 6 hours right there. All right, great. Next one. Okay, we are starting out with 50. When is this radioscope? When is its output going to be 20 watts of power? All right. If 20 watts of power are required to operate the equipment. Okay. So once it gets to 20, it looks like it's going to shut down. So, no. Wait. I should read it. The power P is given by this. If 20 watts of power are required to operate the equipment in the satellite, how long can the... Okay, yeah, so I was right. We've got this one, and this one. So we'll kind of think about our tables in a second. We got 50. Let's delete that. We're going to clear that and go negative x. In fact, let me do a fraction bar. That's the play it safe. Negative x over 250. All right. Table set. We're going to start at, let's see. They have as options, but let's start at 0. What if you just forget? Okay. You can see that okay, 20. You could just keep scrolling, but I got a feeling that I should probably start at about 200. All right, there we go. So 200. Get it right there. There it is. Almost. Right about there. So about 229. 229 days. Okay. All right. So we already know the answer to this, but let's make sure that we got it. We've got to weigh the soap that is decreasing by 2.5% each time it is used. If a bar weighs 100 grams, starting off, how many times remaining when it's 56? So a little over half. So again, we're going to use that E function. Okay, and we're going to have negative 0.025%, because it's negative because it is decreasing, it's decaying. We're going to go from 100 to 56. So let's throw in the x there. If you do forget the x, what'll happen, let me show you what it looks like in your table, because this might happen to you on the test. We're going to go ahead and start at 0. Okay, look at what happens to your table. You'll notice that it's just the same number. Okay, if you find that you get the same number, it's because you got a flat line. That flat line happened because you only put a number there. You do not have a variable that's changing. Okay, so now we're ready to do this. The table's set. Let's start it at 20. Why? Because that's the only option that I have. Let's just verify that it's 23. So right there is where it becomes roughly 56. So we're going to say about 23 times. Okay, we know that the answer to this one is 7 years, but let's verify it. Okay, we're going to go ahead and let's say if this was clear, if you went to your table, you'll notice that it's just empty. Okay, so just so that you know what's going on with that. Bought a condominium for $85,000. It's going to appreciate value 5%. Okay, so if it is will appreciate 5% a year. Okay, so that's interesting. Now that is, you're going to click 5% a year. So this is where we're going to drift away from the natural decay of things, okay? Things that are kind of happening every single moment. This just says it'll appreciate a year. So what we do then is we shift gears to 85,000, okay? Parentheses 1 plus 5%, okay? Then we're going to go ahead and raise it to the x power, and then there we're going to look at when is it going to equal that amount there, okay? So notice the difference. If you're dealing with price values, that's not actually a natural thing, okay? It's not a biological thing. It's a per year type thing. So where do we want to start? I guess we'll start at 7 years. Let's start at 0, okay? And you can see right there, we're at 108,000 happens right there at the 5th year, okay, right there. In fact, there it is. Let's see if it's 93 cents. It sure is 93 cents. So that is exactly where we at. Oh, right there. We are exactly, well, dang it, where are we at? Right here. So 5 years, we go here. Okay, another situation. It is money. It is depreciating, so that should be an unnatural. It's not. It's a money thing. So we're going to go ahead and do simple 1 plus. Oh, wait a minute. It depreciates. That should be 1 minus. There we go. It's going to depreciate at a rate of 20%. Okay, so you can put the 0 there if you want, but it's losing. So basically, you're only going to keep 80% of its value every time. So let's go ahead and raise that to the x power. I don't see any half-life. I don't see anything we need to do as a fraction for the exponent. We go ahead and look at our table. We can start at 0. That's just fine. And we're looking for when it equals $1,600. And you can see right there. Two years. 16 right there. So 16. Here we go. And we are all set. So, I think it was definitely worth taking the time to get fluid with that calculator so that we can do these problems quite well. There's going to be a lot of these problems on the test, okay? So make sure that you're fluid with the calculator. All right, last part of the exam. This is just tables, and I wanted to throw enough of these at you so that you get kind of fluid. It's the same reason why I gave you that maze. I want you to get really good at this stuff. It's pretty useful stuff. What we're doing is we are determining whether or not something is linear, exponential, or quadratic, or neither. What if it doesn't fit either 3 of those patterns? Okay, I believe one of them is. Let's take a look here. One of the things that you'll have to notice is that it is very important that for us to gauge these, that your distances between each of your x coordinates remains the same. Okay, you have to go up by the same amount in order to do these kind of by hand. Otherwise, you're going to have to account for bigger gaps in your data. And you can see that in every single case, we're going up by the same amount. So there's a symmetry to it. Okay, so now we're allowed to use like this little soft skill to figure out whether or not a table is one of these 3 types of functions. All right, so let's go down here. We're going down 12. This guy's down 4. This guy, no, he went down 8. This guy's down 4. This guy's up 12. So let's see what happened. No, up 4. There we go. That was an up 4. He went up 4. That is tricky. So you're going negative to positive, so you went to the right 4. So if you, look at this. You actually added 4 every time, except, no, okay, my bad. I went down 12, okay, then I went down 4, then I went up 8, then I went up 12. Okay, so I'm messing up here. This is going up 8, that is going, that's 4, that's up 8, and then that's up 8. Man, yeah, see, the quadratic ones are a little tricky, especially you go from negative and then go positive. You got to be really careful there. That is a quadratic, okay? I'm actually glad you guys saw me struggle with that one. Quadratics are the hardest one to spot. These guys, I definitely see that went up by 1, then that went up by 2. It can't be linear. Then it went up by 4, then it went up by 8, and I can kind of see a pattern here that if I divided 16 by 8, I get 2. 8 divided by 4 is 2. If I divide this guy by that guy, you'll notice that I get a pattern of 2. So my common ratio there is 2. If there is a common ratio, that's going to be exponential. Exponential. Here we went down 3, down 3, down 3, down 3. That's linear. This guy we went up 3, up 3, up 3, up 3. That's linear. This guy we went 0, then we went up 2, then we went up 4, then we went up 6. Okay, now this went up 2, up 2, up 2. That second difference, if it's consistent, gives us a quadratic. Okay, this guy here. Now I do see that if I multiply, I see these decimals, so it's kind of getting large quick. My guess is that it's exponential. So 2 times what gives us 10? Well, that might be a 5. So is 0.4 times 5, is that 2? And the answer is yes. This 0.08 times 5, that would give us 40. Move the decimal over. That is correct, so that would be exponential. This one is down 1, up 3, up 5. So the difference between these two is 2, 2, and 2. That's a quadratic. This guy is down 4, down 2, down 0, and then down up 2. So that is a difference of plus 2, plus 2, plus 2. That is a quadratic. This guy is here is okay, he went up 6, and then he went down 4, then he went down 3. That's a difference of 10. That's okay, that's not it. 2 times, so it can't be a quadratic, definitely not linear. So 2 times 4 is 8. 8 times 4 is 32. So this is going the wrong direction. This is a neither. Okay. This one is up 3, up 3. This went down 5. No, down 9. And then this one went down 3. Let's do that again. It went up 3, down 9, down 3. This is neither. Okay. So that's it. Be ready for those. You'll have about 4 of those on your exam, so look out. Or just, remember how to do this. Put on your note card a couple examples.